In the last chapter, we learned the basics of running Docker Compose to manage multiple containers as a unit. Our example wasn't terribly useful though. We simply ran two of the same container and we didn't create any relationships between them. In this lesson, we'll set up a composition of containers that all can communicate and work together to form a useful system. The system we will run with Docker Compose is known as the ELK stack. The ELK stack consists of Elasticsearch, Logstash, and Kibana. Logstash is used to collect application logs and send them to Elasticsearch, or a number of other destinations. Kibana is a user interface built to visualize data indexed in Elasticsearch. The three together provide a powerful debugging and monitoring solution for applications. All three components have official Docker images and can be orchestrated through Docker Compose. Here, we see our Docker Compose file, which consists of three services defined. Let's take a look at how we've configured the three services. At the top, once again, we've specified that we're using version 2 of the Docker Compose spec. Next is our services attribute, which houses our three services. Our first service name is Elasticsearch. Here, we'll simply specify the official Elasticsearch image with the tag 2.2.1. We don't need to map any ports since the only processes that will communicate with Elasticsearch are on the same network. Other services defined in the Docker Compose file can access our Elasticsearch container by the service name we defined, which is also Elasticsearch. Our next service is named Kibana, which will run Kibana. Kibana is a web application that allows users to visualize and query Elasticsearch data. Kibana also has an official Docker image, and we will use the version tagged 4.4.2. Just like when we run a single container with Docker Run, we can also map ports to the Docker host with Docker Compose. The YAML attribute we can use to do this is ports, which takes a list of port mappings. Each port mapping follows the same convention as -p with Docker Run, where the two ports are delimited by a colon with the Docker host port on the left and the container port on the right. We can list as many mappings as we need by adding multiple items to this attribute. We can also define environment variables to pass to a container in Docker Compose. Similar to ports, we simply list the environment variable pairs delimited by an equals sign. The documentation on the official Kibana Docker image states that a Kibana will connect to an Elasticsearch instance defined by the environment variable Elasticsearch_URL. Since we can use Docker Compose service names as DNS names, we can just set the value of this environment variable to be a URL with Elasticsearch as the hostname and port 9200, which is Elasticsearch's default port. Since this attribute is a list type, we can specify multiple environment variables if we wish. The next attribute on our Kibana service is the depends on. This attribute exists to express a dependency on another service within the same compose file. This attribute ensures that the dependency container is started first before the dependent container. Compose has no way to tell if a container is actually ready to take traffic though, so applications need to be able to handle multiple connection attempts. Fortunately, Kibana will continue to try to connect to Elasticsearch at startup. This means it's not a big deal if Elasticsearch isn't completely started up when Kibana starts up. Our third service is Logstash, which accepts log data and sends it to Elasticsearch. Logstash also has an official image, and will use the version tagged 2.2.2. The Logstash container specifies an entry point, which is the Logstash executable. This means that like Docker Run, we can use command to pass in arguments to the entry point. For Docker Compose, we can specify a command or arguments to an entry point using the command attribute. Logstash allows us to pass a configuration string in line to the Logstash executable with the -e flag. In our inline Logstash configuration, we're accepting log data via TCP on port 5555, and we're sending the data to Elasticsearch running on our Elasticsearch container on port 9200. Since we'll be submitting logs from our local host, we'll map the TCP port 5555 on the Docker host. This will allow us to use netcat to send sample log messages to Logstash, which will send them to Elasticsearch. Afterwards, we can go to Kibana in the browser and see our logs. Let's run the composition. As you can see, there's quite a bit of output. If you look through the logs, you'll see that Elasticsearch began starting up, and shortly after Kibana began starting. You'll also see a couple messages in the logs saying that Kibana cannot connect to Elasticsearch, but eventually the connection will be made. Now our ELK stack is running, and so we can send log messages to Logstash using netcat. Since we mapped Logstash's TCP port to the Docker host, we can connect directly. Our log message has been sent to Logstash. We should now see it in Kibana. We mapped Kibana's UI port to the Docker host, so we can access it from the browser. We can see in Kibana now that we have a single log message, and it's Hello O'Reilly, which we submitted via Netcat. The ability to set up a complex system like the ELK stack with a simple YAML file is extremely useful for developers needing environments to develop and test software against.